So I'm Miles, and this is just a description of what we did up at the Aardvark Observatory. So we started at the Bay School Saturday morning, and Bay is right over to the left. You can all sort of get yourself oriented in this map. And it took about 3+ hours to drive to the East Bay, through the Central Valley, up the Sierras, and just before Yosemite to get to the Aardvark Observatory. And when we get there, this is sort of the plaque. It was created based on this plaque in April, exactly 6 years ago. And there's an aardvark looking through a telescope. He didn't tell you why it's called Aardvark, but you can ask him at another time. Here's the actual observatory. There are 3 floors to the observatory. There is a dome, and the dome houses the actual 20-inch telescope that is not used for looking through. There are cameras hooked up to it so that you could only observe using a computer. And then from there, you go to the second floor, and that's the observation deck. The observation deck has a actual telescope you can look through. So while the students are controlling the telescope upstairs to take pictures of objects, our students downstairs using a computer to control another telescope so that you can see what those objects look like with your naked eye. And then on the first floor is the control room, which houses the computers that control all the telescopes and the imaging computers that allow you to process the images. And so here's a schematic of the telescope, the observatory itself. The telescope's on the top floor, and then we're going to sort of work our way down, starting from the top to the observation deck, and then down to the main control room. So here is the telescope itself. It's 20-inch in diameter. So this image right here is about to scale. Okay, it's just a little bit bigger than this if you sort of imagine it 3-dimensionally. And here is the observation deck control room, where you have a computer that controls the observing telescope, and see that it's red lights, because the red light doesn't affect your eye as much in the dark. And then here you can see the actual telescope, and Alex looks a little bit miserable because we were there in February during the winter. So this is probably around like 11 o'clock at midnight, where it was very cold. And here's Christian looking, mystically up in the skies, not through the telescope, as people pointed out. And then in the warm, downstairs, you get to sit in the control room. And when we are actually operating the telescope, there are different groups in charge of different tasks. Students are in charge of the star party in the second floor. Students are downstairs operating telescopes. There are students operating the camera. And when things are happening upstairs, you have to shout out through the observatory to tell people things are happening. Otherwise, if they were up in the telescope room and they didn't know the telescope was moving, they can get hit, or other things can happen. So everybody had a different task up at the observatory. And here, so this is, obviously when we go to a nighttime and we want to be able to have students downstairs have their eyes adjusted to the red light and then go upstairs to view what they're actually imaging. So here's a typical view of what you would see. A lot of these pictures are taken by Sam Lopez, who is really a very good amateur astrophotographer. Right? It takes, if you ever try, have any of you ever tried to take a picture of the stars in the night with your phone or camera? No. There's no need to try, because it'd just be a dark picture. It takes a while to learn how to actually get the stars to show up. And so here, anybody see the constellation? Yona. Orion. You can see Orion. So Orion is right there. Okay. You can see on the right side it's the bow and arrow, and on the left side it's the club. And so, this is typically what you see when it's very dark. But the problem is the stars all move across during the course of the night. So because they move from this long exposure, you can see that they move across the sky. The telescope itself has to move along to follow it. But because the telescope is moving, it actually rotates too. So as it takes pictures throughout the night, not every image is the same. And you have to be able to compensate for that. And that's sort of our biggest task when we're imaging. So in this picture, I wanted to show you in the night sky what an object would typically look like. This is one of the biggest objects in the sky. Anybody see it? No? No, not the mountain. The object we're looking at is about 100,000 light years across. If you can't see it, it's right here. So that's the Andromeda Galaxy. Okay? If on a clear night, you could barely see a fuzzy thing. This picture shows it much better than it actually is. Okay? So when you look at it through a telescope, it's still a fuzzy picture. It looks just like this. Okay? Through a telescope, that's what it looks like. If you look at a telescope, you're like, what's that fuzzy ball? And it's the Andromeda Galaxy. So now, some of you guys have seen pictures of the Andromeda Galaxy, and it looks like this. Right? Using the Hubble Space Telescope, you can get a picture of the Andromeda Galaxy that looks like this. So how did mankind ever go from imagining that an object that looked like this could actually be something that is hundreds of billions of stars? And so up at the observatory last year, during the fall, we were able to use the telescope to take our picture of the Andromeda Galaxy, and we were only really able to image the central bulge region, and Charlotte, her image process looked like this. Okay? So it's a big jump to go from an object that looks like this to actually having an image that shows details. There's dust, there's star clusters that you can see. So this is sort of the first night, learning all these details about the observatory. So when we look at images, they pretty much look like this. Right? You can't see many details when you take just one picture. And part of our imaging task is to take many, many pictures over the course of the night and add them all up. And it's very difficult to add them all up because, like I said, all the pictures move, so they're all a little bit different. And not only are they a little bit different, because the objects are so faint that each of these stars that you see are actually all different shapes in every picture. So when you add them up, you can get a big blurry mess if you don't do it properly. And that's where sort of the art of this comes in. Everybody who does it in a different way. It's not like the software is just automatic and you are able to just add them up and have it be pretty all the time. But this image is sort of the plain view. After a little bit of contrast adjustment, this is the Rose Nebula. And if you look at it, these next three images are taken over the successive sort of parts of the night. And you can see that they shift a little bit. So you have to be able to add those images together such that you don't just get a trail of lines that go across. You have to put them in the right spot. And here is a zoom of what this one star in the red part looks like. And so with each successive image, you can see it looks like this, it looks like this, and it looks like this. They're all different. You can't just say, I'm going to line it up perfectly in the center, because every center is a little bit different. You can tell from the little images that they're all different shapes. And so where is the actual center? It's very different for each person that actually does it. So if you take these three images, you add them up, you can get something that looks like this. Okay, the side projectors look a little bit better. So this one was processed by Ben Foster. So this is the Rose Nebula, and it's called the Rose Nebula because when you see the entire nebula, it actually looks like a rose. So this is what's taken by the Hubble Space Telescope. And you can tell that it's the same image because from the sort of central star and the two on the top and the two on the bottom, you can see the two on the top, one in the middle, and then two on the bottom. So this is the Rose Nebula. Okay, so with Hubble Space Telescope, it's doing something similar, and then there are other sort of artists that sort of do the post-processing with it. And this is the Hubble Space Telescope. It's in space. But this telescope is not actually that much different from the one that we use at Aardvark. It's just a little bit bigger. It's actually not that much bigger. So the next day, we took a little journey from looking at natural beauty in space to Yosemite, looking at pretty things on Earth. And this is taken by Sam Lopez, and these are students looking at the natural beauty of the rocks. And here's a cute picture of kids skating, holding hands so they don't fall. Here's one that's almost as cute. Here's a picture of our very own Samsel Adams Lopez. You can see the half dome with the moon. And so back to the observatory to process some images. So just the last couple of images that we're going to look at is the Horsehead Nebula. And so just by taking about 30 of these images, we put them together to show the Horsehead Nebula, which looks like this. You can see the horse head there. And then here's one of the Pinwheel Galaxy. And this one is done by Ben Foster. And you can see some details, but you can see that when we actually do image processing, we can not only see that different people make different images, but you can play around with different settings and be able to see different features. And so this is one done by Sam Lopez. And then this last one is just what the Hubble Space Telescope is able to do to show you all the different parts of the galaxy. And so here is the happy group after observing the observatory. So I'd like to thank again Gary for making this opportunity available for the Bay School students to be able to really experience what it's like to not only do astronomy, but to be able to bask in the wonder of everything that's out there. And hopefully you'll take the astronomy class and be able to not only go on this trip, but to learn about what all those objects actually are. Thanks.